Okay, let's do some of these mole conversion questions. So we're going in the first one here, we're going to go from moles. Actually, we're going to start with grams. We got 15 grams of lithium, and we're going to convert it to moles. So lithium is just an element. Lithium is Li, solid. Now, let's look at our formula that we're going to use. Over here, I've written out the formula. This formula is on your page 10 of your textbook, of your data booklet. So you don't have to memorize that formula, but you do have to be able to rearrange that formula. So I would suggest learning how to put that into a triangle or knowing how to mathematically rearrange an equation really well. So these triangles have been really handy in the past. So because we have mass, that's what this is up here. This is our mass. And down below we have molar mass. Because mass is on top, we have to put it in the top of our triangle. Molar mass is on the bottom. And then we'll put moles over on the other bottom part. So this is moles. This is all labeled too on that page 10 of your data booklet, so it's very helpful. So then if you need another formula, which we will later, we can use this triangle. Okay, so let's continue with our first question. I'm going to bring it down to here. So we're looking for moles. So we're looking for N. I'm just going to use the highlight. We're looking for N. So our formula is going to be mass over moles. If we cover up our N, that's how our triangle works. So N equals, or moles equals mass over molar mass. And our mass is 15 grams of lithium, and our molar mass is taken from our periodic table. We just have to look up lithium, which is Li, and it's in the first column, and its mass is 6.94 grams per mole, right off of the periodic table, because there's just one lithium in lithium solid. So we're going to divide 15 by 6.94, and we get 2.16 moles. So that's our answer for the first question. Question number 2. How many grams are in 4.5 moles of sodium fluoride? Okay, so we have gram. We're looking for grams, and we have moles. And we are given a compound in this case. So whenever we're going between grams or mass and moles, doesn't matter which way you're going, you always need the molar mass of the substance. Okay, so we're first going to have to find out the molar mass for sodium fluoride. So let's add up sodium. Find sodium on your periodic table. It is 22.99, and fluorine is 19.00. So our molar mass for the compound is going to be, there's only one of each, so that is 41.99 grams per mole. So that's the molar mass. All right, now that we have the molar mass, we can pop everything into our formula. Now we're looking for grams now, which is mass. So let's go over to our triangle. Here's mass. So mass is on top. We're going to cover it up. We're not going to be using it. So it's going to be moles times molar mass. So mass is equal to moles times molar mass. Let's sub everything in. So we've got 4.5 moles from our question times by our molar mass for sodium fluoride that we just calculated, grams per mole. And put that in the calculator, 4.5 times 41.99. And it's 188.955. Now, I made a mistake last time, or did I? No, I didn't. Yes, significant digits. We have to go back to our question and check that out. So first off, this is mass, so it's grams. In our question for number 2 here, there is only 2 digits in our question, so our answer can only have 2 digits. So significant digits, we're going to round up 190 grams. Okay. Now let's go back to that last question. There's only 2 digits in our question, so there can only be 2 digits in our answer. So we're going to round this up to 2.2 moles. Okay. Question number 3, I'm going to do in another color so it's a little easier to see. And I'll do question 3 down here. How many moles? Okay, so we're looking for moles again this time, which is N. See how I'm always circling this stuff in the question to identify what they're actually asking? That's a really handy tool technique. So how many moles are in 98.3 grams? Grams is mass of aluminum hydroxide. Okay, again, here is our substance we're dealing with. So we're going to need to have a molar mass if we're going to be moving between moles and grams and moles. So the first thing I'm going to do is find the molar mass for aluminum hydroxide. And I actually am going to cheat. I have this already, but we're going to get the mass for 1 aluminum from our periodic table, and that is 26.98 grams per mole. And then we're going to get 3 oxygens, right? That little 3 down below means there's 3 oxygens, and then there's also 3 hydrogens in there. So oxygen, there's 3 of them, and each one is 16.00 grams per mole. And for hydrogen, there are 3 of them again, and each hydrogen is 1.01 grams per mole. We add all that up, and we get a molar mass of 78.01 grams per mole. I'm not going to round anything off until we get to the end of the question. Now, going back to the question, we're looking for moles, N, and we can use our nice little triangle here, or our formula from the data booklet, and moles is equal to mass divided by molar mass. So our mass given to us in the question was 98.3 grams, and our molar mass we just calculated for aluminum hydroxide, 78.01 grams per mole. Divide these two. 1.26 moles. Now I'm just going to double check. Yep, there's 3 digits there and 3 digits in our answer. So we're done.